Our objective is to determine which external factors have the most significant effect on how fast a Texas Tech cross-country runner can run 1 mile. Our hypothesis is that our 6 factors chosen, including temperature, wind speed, humidity, time of day, running surface, and shoe type, do not have a significant effect on a runner's mile time.
In order to block out nuisance factors like gender, height, weight, and running ability, we only used one runner in our experiment, and that is our group member, Hattie.
Hello, today we are here at Texas Tech Track Practice to watch Hattie run 2 of her mile times for our analysis. She will go into further detail which exact factors we are recording today in the next clip. So, due to time and resource limitations, and because I can't physically run 64 time trial miles in a couple weeks, we decided to do a fractional factorial design with 6 factors, so a 2 to the 6 minus 1 design. Our 6 factors were already discussed, and today I'm going to perform 2 of those replicates, so I'll run 2 time trial miles. Today's conditions are, the temperature is about 82 degrees outside, so that's a high level. The wind is about 9 miles per hour, which is considered low. The humidity is only about 28%, so also considered low. My choice of shoes today are spikes rather than flats. I'll be running on track as the surface. And then also the time of day is afternoon. It's about 2 p.m. and I'll get started here in a little bit. So now I'm going to warm up. So after the time trial miles are performed on the track, the data is uploaded from my Garmin GPS watch, which is shown here, to the Garmin Connect database via Bluetooth. And all Texas Tech athletes use this Garmin database to record our workouts. So you can see here today, for myself, Hattie Shunk, at 3:45 p.m., I ran 4 laps around the track, which is exactly a mile. The conditions were 84 degrees, 8 mile per hour winds, and about 25% humidity. You see here my time was 5:31.2, and again, we used the distance of the track rather than the distance recorded by Garmin. You can also see my notes over here, which show that it was a track workout performed on a track surface, and that the shoes I wore were Under Armour spikes. So this data is then recorded in our design matrix. As you see, the second highlighted portion shows that data, and the first time trial repeat was 5.51, which was 5 minutes and 31 seconds. The second one I won't show, but the same method was performed. Now, to obtain the rest of the data, we again use the recorded data in the Garmin Connect software for my repeat miles that have been recorded over my past 4 years as a Texas Tech cross-country runner. So to illustrate that, you can come here, I can go to my calendar, and here we're going back to October 2017, looking through my workouts, and you see we performed mile repeats again on October 24th. So if I click on this one here, I can see the details of that workout, and again, it was mile repeats on the track. I actually ran a similar time, 5 minutes and 30 seconds, although the conditions were a little bit different, 39 degrees, 6 mile per hour wind, 70% humidity. You also see here that, again, it was performed on the track, but in the morning this time at 7 a.m., and I was wearing a different set of shoes, flats. So for these conditions, those are recorded right here, this first highlighted portion, and that illustrates 2 different conditions of our experimental design. Now, the rest of the data was obtained from this Garmin software, and it was obtained at random, and you can see that by the random nature of these dates on the side, and the actual method that we used will be included in the report.
Contrast and effect estimates were determined and an ANOVA table was formed. A significance level of 0.05 was used, and it was found that factors A, B, E, F, and interaction CE, which correspond to temperature, wind speed, surface type, shoe type, which is our alias, and the interaction between humidity and running surface, all have a significant effect on Hattie's mile times. A normal probability plot was constructed to verify which effects, if any, were significant or not. As illustrated, the effects that are negligible are typically normally distributed around 0 and fall along a straight line on the plot, whereas significant effects will have a non-zero mean that does not lie on the straight line, essentially outliers. According to our plot, the same factors that were significant based on the ANOVA test are shown to be significant to Hattie's mile run time, as they are outliers in the plot and do not follow the linear trend that occurs near 0.
The equation shown is the effects model that we generated based on the significant factors that we found. Using this effects model, we calculated predicted responses or mile times at each condition and compared them to the actual result. Then a residuals versus predicted yield plot was constructed. The random nature of the residual plot and relatively even distribution around 0 indicates that our effects model is a good fit.
In conclusion, we discovered that at least one of the factors was significant, so we reject our null hypothesis and conclude that there are 4 main factors that affect Hattie's mile time, plus an interaction term.
According to our analysis, wind by far had the most significant effect on how fast Hattie was able to run her mile. The other factors were similar to each other in magnitude, but did not compare to the wind factor. Based on further experiments by including more runners to vary gender, height, weight, we could look into whether or not these lower level significant factors were actually significant.
Of the 6 factors I told you about, which ones do you think affect your mile time most significantly?
I would say definitely the wind, but of course a mixture of heat and wind is always the worst.
Okay, interesting. Thanks. So Lauren, of the 6 factors I told you about, which ones do you think most significantly affect your mile time?
I would say the surface we're running on. I feel like I always run a little slower when we're running on the grass, and when we go to the track, our times are always faster.
Any of the other ones?
Definitely wind, especially here in Lubbock.
Yeah, I would say so. Thanks. So, to bring everything together, our conclusion that wind is the most significant external factor on cross-country runners' mile times supports what most Texas Tech cross-country runners themselves believe to affect how fast they run 1 mile. In fact, I think my team might just have to bring this data to the NCAA to petition for a wind conversion factor.